In the previous video, we were introduced to centripetal force and what equation we will use to solve for it. Let's now take a look at an example of a centripetal force calculation. An automobile of mass 1,640 kilograms follows a curve of radius 25 meters with a speed of 15 meters per second. What centripetal force is exerted on the automobile while rounding the curve? Our second part will be identifying what exerts this force. First, we know centripetal force is equal to mass multiplied by speed squared divided by the radius. We can substitute in the values we know. The mass is 1,640 kilograms, the speed is 15 meters per second, and the radius is 25 meters. Multiplying 1,640 kilograms by 15 meters per second squared, we get 369,000 kilogram meters squared per second squared divided by 25 meters. Doing the final division step, we see the centripetal force is 14,760 newtons. Now we have to answer the question, what exerts this centripetal force? You can kind of think of the centripetal force like the normal force, which we discussed in a previous chapter. In this case, the pavement on the tires exerts the force. A great example of the centripetal force in action is the Wall of Death. The Wall of Death is a carnival sideshow where motorcycles or mini cars travel along vertical walls. These cars are held in place by the centripetal force. Essentially, how they stay in place is the push force, or the normal reaction force of the wall, supplies the centripetal force. This concludes our discussion on the centripetal force.